Hey folks, so in our last video we had a up and running Grafana dashboard, right? So what you can see here is I just provisioned the new machine, one RTX 4090. You can see the uptime is less than a minute. So let me just run that command, and you can see it's only been 2 minutes that this machine is online now. So based on our last video, we need to clone this repository. So let's just go HTTPS. Let's get that, and then let's run the clone. So once that clone is completed, let's just go to our GPU directory, and here we need to go Kubernetes single node setup, and then all the scripts that needs to run is over here, right? So all I'm gonna do is I'm gonna run all.sh. So this will complete all my installation. As mentioned previously, it will give us a running Kubernetes cluster as well. So while this is going through, there are a couple of things I want to talk about, right? So today we'll talk about this. We have a running Kubernetes cluster, but we won't be able to pull the GPU matrix straight away, right? We are exposing our DCGM pods, which is a daemon set. So what a daemon set means is that each node will have one of these pod, and then we know DCGM pod exports the GPU matrix, right? So this pod should be in every single node. In our case, we only have one node, so we'll only see one occurrence of this DCGM pod. So when we expose pods, right, in my current setup, we are exposing pods by a service. So in our service, we define certain things like labels. So here we would say that, hey, listen, look for a pod that is known as DCGM, right? So it goes out and it will find out the pod that is called DCGM, and then it will say that, okay, that pod belongs to my particular service, this is the IP address of that pod, and this is how I'm going to expose it. So that's how you talk to a pod in my setup, right? So for Prometheus to know and go and collect all the matrix from the DCGM pods, it needs another thing called ServiceMonitor, right? So essentially what ServiceMonitor does is that it's a CRD. So CRD is a custom resource definition. So it's a CRD from Prometheus stack. So what this does is that it will monitor for a service. So essentially what we will do is, similar as service, we will write a YAML here where we will say that, hey, listen, I need you to monitor for a service that is known as DCGM service. So once it sees that service, then it will know what kind of information are those service exporting, right? So for instance, it could be, okay, what port is that service exposing its matrix on? What are the endpoints that service knows? So there might be, let's say, 5 pods, right? So 1, 2, 3, 5, for instance, and then we might have a cluster of 5 pods here. So what happens is, exposed by a service, we will know that there are 5 pods in this cluster that I need to know about, and then it will expose the IP addresses as well. So that way a service will have a collective information of all the pods with its IPs. So if a Prometheus pod needs to talk to our DCGM pods, with the help of service, it will know how many DCGM pods are there, right? So it will be aware about the IP address of all the DCGM pods in our cluster. But for Prometheus to make aware about a service, we need a service monitor, which maps to a service. And then once it maps to a service, Prometheus pods will know everything about DCGM, right, through the service. So we'll see this flow in our cluster itself, so it will make more sense. And once we have all of that information collected, then we will we'll have our Grafana dashboard, which fetches data from Prometheus. I think from a very high level, if I have to reiterate this, essentially what happens is you have a bunch of pods in your cluster. If you are exposing these pods in your cluster, then what you need is you need a service, right? So this service will go ahead and then it will know about the pods. So what does it know? It will know about the port that it's exposing its matrix on. It will know about its IP address and so on, right? So once we have that in the service, Then for Prometheus to know about that particular service or about the pods end of the day, right? That's how you should know. That's where you pull your matrix from. It needs a service monitor. So essentially what service monitor does is that we define a service monitor with a label saying that, hey, there's a service called DCGM. I need you to know about that particular service. And then service monitor goes, okay, let me look at all the services in the cluster. Oh yeah, there we go. I find a service that has a label DCGM. So the service has 2 ports in the cluster, and these are the ports that it's exporting, and then that information is fed back to Prometheus. Now Prometheus goes, okay, so now I know the IP address and the ports of the pods that I need to connect to, and then it can connect directly to the pods. So essentially that's the flow, but this will make much more sense once we have our cluster up and running. So let's have a look. We are almost done here. So there's one thing that's been added, right? So that's been added in the new repository. It installs PyTorch as well, because when we run GPU testing, we need PyTorch, right? So I have my cluster set up. So let's just go and actually before this, let me just run a tmux split screen. So we discussed about how we can reach the Grafana dashboard from our local machine, right? For that, we need to run our SSH command, map the port. So let me just copy the connect command, and then let me share that here. So that information is shared here as well, right? So what I need to do is that I'm exposing my Grafana on remote port 80. So I'm mapping my localhost port 3000 to my remote port 80, right? So now once I have that SSH tunnel established, then only I can go ahead and run the localhost command. So now you can see my Grafana is there. And then by default, Grafana uses the same admin password. So you can actually get that from your kubectl command as well. Or in my case, since I've been doing this lab quite often, I have it saved. So I log in, and then I have a working Grafana dashboard in my Kubernetes cluster, right? So let's have a look at all the pods here. So kubectl get pods -a, and then let's just make sure that all of our pods are running, so we can see all of the pods are running. Or a better command would be to just go grep -v. So -v essentially negates what you're putting in your filter. So essentially it's asking for, give me everything except from running. So we see there's one job here, which is NVIDIA CUDA validator. It's on a completed state. So it's a job, it's not a pod, right? So it did its job, and then it's, you know, it kind of like, yep, once you start up the cluster, I'm just validating my CUDA matrix. If there was something wrong, I'll let you know about it, but you know, it has done its job, so we're okay, right? So now when I mentioned about DCGM, right, we know that pod here. So let's go kubectl get pods in our default namespace, and we know that our DCGM pod is the one that is responsible for sending GPU matrix. So if I go to my Grafana, and if I go to my dashboard pages, and so by default there are some dashboards that we see here, right, because of the Prometheus Kubernetes Prometheus stack. So if I go and have a look at, for instance, let me go and have a look at Kubelet, right? So we talked about Kubelet before. Kubelet is an agent that sits in a node, and then that agent sends the information about the cluster back to the control plane, right? So think of Kubelet like a captain of each node. So if a node is, you know, if we have 2 nodes, then we'll have 2 kubelet, right? So each node will have its own kubelet, and then kubelet is responsible for sending all the information back to the cluster. So we can see here we have, you know, so this is an example that the dashboard is actually working, right? So it's only been a while that we have our machine up. So let's go uptime again. We see it's only been 11 minutes, but then all the packages that have been installed, probably less than 5 minutes. So let's just go 5 minutes. So this is when we see matrix in our dashboard, right? So it says 1 running kubelet, which makes sense, because if I go kubectl get nodes, I'm running a single node cluster. Then I have 24 running pods. I have 44 container. So see this one 1/1. So that means in this pod I have 1 container, and it's in a running state, right? But if I were to go kubectl, if I go kubectl get pods -a, here you can see that this is 1 pod Grafana, but it has 3 containers running, right? So that's why the number of pods and containers are different. And then there are a bunch of other matrix here as well. So essentially what this tells me is that I have a working Kubernetes cluster, and I am able to pull the matrix. So if I go to dashboards and to create a new dashboard, so let's just go new dashboard, add visualization. So Prometheus is our data collector, right? So if you have any other data collectors, you would see that option over here. But in our case, it's Prometheus. So we'll just click Prometheus. Actually, let me just change the theme to light theme for now. Just makes it easier. And then, so once I have that, we talked about DCGM being the matrix exporter, right? So if I go here and if I do DCGM, you can see there's nothing, right? So if I go to the matrix explorer and if I go DCGM, you know, those were the hits from my previous search because I've built this dashboard, but you can see that there are no matrix for DCGM, right? And we know the reason why, because we don't have a service monitor that's exposing the DCGM service to Prometheus. So let's have a look at that. And then actually, let me just pull my Firefox as well. So if we go to our cluster and if we go kubectl get service monitor, in all namespace, we see there are a couple of service monitors, right? So these service monitors talk to the service, and that's how data is fed to Prometheus. But we don't see anything for DCGM. So if I go and if I look for a service, kubectl get service in all namespaces, so we see a bunch of services, but ours is in default namespace. So let's have a look at that service. So kubectl get service and then NVIDIA DCGM Exporter. So we have the service up and running, and if I get the YAML of the service, we will see the bunch of spec that the service has defined, right? So it says that, okay, it's exposing its matrix on this port 9400, and then the name of that port is called GPU-matrix. It has a selector called NVIDIA-DCGM Exporter. So it only looks for the parts that have NVIDIA-DCGM Exporter, and then these are the matrix that it will be exposing information on, right? So we need a service monitor that matches that similar spec, right? And here as well, we talked about this particular situation. So this is our service, and then the parts exposed by this service are our NVIDIA DCGM Exporter. In our case, we only have one part. So if I go kubectl get parts, kubectl get parts -a, and then grep for NVIDIA DCGM Exporter, we see there's only one part because we only have one node, right? Because this is a daemon set. So what daemon set means is for each node, there should be one part. That's how our daemon set works. If I have 5 nodes, there will be 5 parts because it's a daemon set, right? So we have kind of understood this flow. So we have a service, we have parts exposed by the service, and then the parts exposed by this particular service here are our DCGM parts. We are selecting it with a particular label called NVIDIA DCGM Exporter, and then it's a daemon set, which means that each node will have one part, right? So we have this part covered, but still our Prometheus is not aware about that particular service, because when we go here and when we type in DCGM, it says no matrix found. So in order to fix that, we need to create a service monitor that maps to this particular service, right? So within that repo, if you go to, actually, I'm already here in my screen up above. So if I click on ls, so I will see the YAMLs directory, right? So let me go to my YAMLs, and then if I do an ls here, I see this service monitor GPU.yaml. So let's have a look at that first before we go ahead and create the service monitor. Okay, so what we've defined here is the API version, the kind is service monitor, and then we're naming it, you know, DCGM-exporter. It's going to be on the monitoring namespace. And then this is the most important part in YAML, right? Essentially, we know our service is in our default namespace. This is what we did, right? So when we did in our screen up here, let's just go up, and then, so we know this is in default namespace because we did not mention any namespace here. So when you don't mention any namespace, it's default. And then we said that match the label that is NVIDIA-DCGM Exporter. So we did match that label, and then we say that the endpoints are exposed on that particular port, GPU-matrix. That's all it needs to know, right? So we did see that here. So when we got the YAML of our service, see the ports that it's going to expose are going to be on GPU-matrix, right? So we don't need other port information as long as we have our endpoints being exposed on that particular port. That's enough for us to reference. So two important things to pick the right service would be the label, match the label, and then if you go and have a look in your service, you'll see we have it defined as label app NVIDIA-DCGM Exporter, and we used Helm charts to create this, right? So these are the default values that have been created. Once we have that, the other important thing we need to do is match the port. In our case, the port is GPU-matrix. We're going to expose it in HTTP. Every 15 seconds, we're going to pull for the service. So every 15 seconds, if a change is made in the service, maybe we add another selector here, then in the next 15 seconds it will know, okay, we're actually exposing more pods now. It's not just one pod, there's another pod being added. So that's how the flow works. So we see how service monitor maps to a service, and then service maps to the underlying objects, right? So let's save and quit this, and then to apply this, we have to run this command kubectl to create this. Let's say kubectl apply -f ServiceMonitor.yaml, and then okay, unknown field space.name space match names. Okay, let me just have a look. I think there might be a typo here. Let's go back. Okay, so I think the typo I was complaining about was this. It should be capital match names. And then the other important thing I need to have here is my labels as well. So this is going to be release Prometheus. So this is important to have my Prometheus release labels, and then that's the match names. So let's hope that will work, and then apply -f new ServiceMonitor.yaml. Okay, strict decoding is spec.endpoints 0.ports. Okay, so what is wrong in ports? Okay, yeah, so I think the problem I have here is this should be singular, it should not be ports. Let me try that again. Okay, so now finally the service monitor is created. So kubectl get service monitor -n monitoring. Okay, yeah, so now I see my DCGM-Exporter service monitor is created. I'll make sure to fix the typos and the error I got in my next git push, so you won't face this problem. So now if I go back to my Grafana dashboard, right? So if let me just close this, and then let me go to the Matrix Explorer, and then if I type in DCGM, so it still says it can't find the matrix. So usually it takes some time until it will see, until this gets feeded back to the cluster, right? So the other option we have is to restart our Prometheus pods. So let's see if we have kubectl get pods -a, and then get PR. So we have our Prometheus Grafana pod, but instead of restarting, I'll just give it some time so that it completes its sync. And then it shouldn't take that long, so let's just go DCG. Okay, and let's just wait for a bit more. 1, 2, 3, waiting. One, two, three, waiting. Okay, even after waiting for a while, we still don't see the oh, okay, we do see the matrix now. Okay, there we go. Yeah. So what I was going to do was, if I don't see the matrix in a while, I was about to restart my Prometheus Grafana deployment set, but that will trigger the restart of the pods. But now it takes maybe 15 seconds, right? Just give that 15 seconds and you'll see this matrix been populated up here. So now what we can do is, now we can start building our dashboard, right? So let's expand that. And then initially before, right, we did see that if I go to my Matrix Explorer and then if I type in DCGM, it was showing blank. But now we see there some default matrix exposed, right? Of course we can we can add more to this, but for the time being I think we have enough to get started. So what I'm gonna do is, let me add GPU utilization. So let's just go, instead of last 6 hours, let's select last 15 minutes, and then let's run the query. So we see we're getting something here, right? So it's currently 0 because we haven't done anything. So let's just rename that to GPU utilization. So skip the description, and then my unit is gonna be miscellaneous, and then percentage 0 to 100. So that way we get it in the percentage matrix. And then I want to change my graph a little bit as well. So let's go to graph styles. Let's change that to faux. I like it like this. And then some bendy graphs are good. So let's pull that up. And then actually, while we do this, right, what I would prefer is let's run some workload in our GPU so we can see some movement, right? So after I'm done with creating that service monitor, what I need to go is I need to go to our Python directory. So let's go to our Python scripts, and then we have this here called continuous matrix multiplication, right? So what we need to do is we need to activate our virtual environment. So let's just go ahead and do that. So for that, like Python virtual environment, right? So I am creating this environment here. So venv. Okay, so let me let's create a new environment actually first. So Python 3 -m venv s torch. Okay, so once we create our virtual environment, let's go ahead and activate it. So venvs, and then torch bin activate. Okay, once I have that activated, so let's make sure that my PyTorch is installed. Go pip install torch. Let's install torch. Let's install PyTorch. Actually, I think that should be enough. Okay, so while the PyTorch is being installed, we can build our dashboard, and then we'll come back to this. Okay, or let's see if that's completed straight away. There will be further packages, but yeah, we'll come back to this, right? So now we have our GPU utilization, and then you can see here a bunch of other legends out there as well, right? So I'm only interested in my UUID, so let me just copy that and then go back to option, and then in legend option, just go custom and then delete the label name, just add that, and then just run queries. So there we go. Yeah, so that's our GPU UUID, and then that's our GPU utilization so far. So go back to dashboard. Once we kick off more things, we'll see some matrix being pulled over here. So let's just make sure that we have the right metric collector. So GPU utilization, and then okay, let's just go here, GPU utilization. Yes, GPU utilization. Let's refresh. Just 5 minutes, 15 minutes. Okay, so my default is okay. I think for some reason my the value of my left is gone. Okay, so I don't want to do any override. Okay, yeah, for some reason there was an override, but anyways, now we have it back. So I'm going to create another one. So let's go add visualization. So in this case, let's go ahead and let's look at our GPU temperature, right? So let's go DCGM, and then you can see it kind of gives you a description as well about what each matrix does. So we see here GPU temperature. So let's pull that in. Let's run the query, and then let's change a couple of things here as well. So let's change the graph to that. Let's change the line width to faux. And then for my GPU temperature, probably I don't want a lot of these things. I'm happy with UUID again. And then so let's go options. So essentially this will be useful when we have multiple GPUs, right? Or when we change our, for example, like for each node, we can have a unique host name. And then when we have multiple GPUs, let's say if we have 5 GPUs, right? So to know the temperature of all of those 5 GPUs, we'll have this matrix here. So That's when the labeling is important, right? Because you'll be able to know how many GPUs and use multicolors and so on. But for here, we need to change our left hand side metric, right? So what I want, since this is temperature, I want Celsius and so on, right? So I need to click on my let's go to standard options, let's go to the unit, and then we are concerned about temperature. It should be in Celsius. Okay, so that's it. Yeah, so we see that right now it says it's at 32 degrees Celsius. So let's just confirm that NVIDIA-SMI, and then where is the temperature? 32 degrees. Okay, so that is another indicator that we have the right information, right? So after we have our PyTorch environment set up, so let's run the script here, Python 3 continuous matrix multiplication. So it does multi matrix multiplication, and then that essentially will spike up our GPU usage, right? So it's a clean way to increase GPU utilization. So now let's go back here. So let's go back to our dashboard. Let's bring this guy here, and then let's rename this as well. So instead of okay, actually let me go back, let me go here, edit, and then this is our GPU temperature. So we should see some movement in this matrix because we have kicked off a job. We should see the utilization and the temperature going back up, but it takes some time. Well, there we go. So we see our GPU utilization was essentially 0. We went up to 100%. Our GPU temperature was at 32 degrees Celsius. Now we are up all the way to 63 degrees Celsius. If I run my command NVIDIA-SMI, that is reflective. My GPU utilization is 100%. My GPU temperature is actually 70 degrees Celsius now. So you see it's it keeps climbing up. That value will change by default to set up with what's been reflected. So initially it was 60, went up to 70. So let's keep adding more dashboards, right? So let's go to visualization, and then let's have a look at the Matrix Explorer. So let's do something with memory now. So we see that says the free memory, right? So let's add that, and then let's go here, let's say free memory. So let's run the query. We can see that as well. So initially there was a lot of free memory, but now we don't have much free memory. So let's change a couple of things here as well. So let's go to graph styles, and then that will be changed to full. We'd prefer something like this. And then the other important thing would be to change the unit, right? So unit is going to be data, and then I think it's in maybe bytes. Yeah, okay, there we go. So if we look in our vast.ai, we see our VRAM is 24 gigs. So here we see, our free memory was almost close to 24 gigs, 23.5. But now our current free memory is very less, like it's around, say, 19 gigs is free. We are using the rest of the memory. Here we see that our memory utilization is around 3 gigs. So that matrix is reflective of what we want to see as well. So far we have our free memory. So initially we had 23 gigs free, but we have around 19 to 20 gigs free. Our GPU temperature is climbing up, our utilization is climbing up as well. So let me add another panel here, visualization, and then let's go to Matrix Explorer again. So we did the memory free. We can use the memory used for this, I think. So let's go panel option, let's go memory used, and then the same stuff here. So I just want that, and then I kind of find it easy to read it like this. That's why I picked that graph style. And then let me just go run the query. So this is memory used, and then we have to change this unit again. So this is going to be data, and then it's going to be maybe bytes. Yeah, so we're using almost 3.7 gigs of our memory, which we see here, right? If I run my NVIDIA-SMI command, so it's 3856 megabytes. So we see that it's it's close to that, right? It's 3.7 gigs, so it's pretty accurate, let's say. So let's go back to our dashboard, and then let's bring that up here. Okay, so we have our memory used, our GPU temperature, I have our free memory, and then GPU utilization. So now we have a working Kubernetes cluster. And then we have our Grafana dashboard as well, where we are monitoring our GPU. So this is just an example for now. I know this dashboard is still super basic, but at least this tells me that it's working. I can see a couple of things. Eventually, when we work on more complicated stuff, we will have better dashboards. And I am new to building Grafana dashboards too. I've used Grafana extensively in my work, but it's I've used it when someone else built the dashboard for me. So now I've realized building dashboards is not as easy as it looks sometimes, or just probably all the matrix that you can utilize here is it's really vast actually, but we'll get there. So let's see if there is any other matrix that we can use. I find this quite easy for now, just to go DCGM Matrix Explorer. Okay, so we saw the memory, we saw the GPU temperature, utilization. Okay, so we saw the power draw as well. Okay, I think that is an interesting one. So let me just add the power draw. Then let's run that query. Okay, so we see the power draw going up as well. So let me have a look at my NVIDIA-SMI here. Then let me see what the unit is. Okay, so the unit is watts, right? So right now it's around 401 watt or 397 when the last time Grafana fetched that data. So to change that to watts, I need to go, well, let me change my graph style first. Prefer that. Let's go to full, and then let's go to our unit, and this should be energy, and then in energy we're looking for watt. It's not watt per hour, it's purely just watt, right? So let me see if I see that option. Okay, energy. Okay, there we go. Yeah, watt. So that's the unit that we're looking for. And then for in terms of legend, we can just go custom as well. If I just want something like power, I can just set that to power, and there we go. It just sets power, right? So let's go back to our dashboard. So let's let me expand this guy a bit here. Okay, so now we have a dashboard where we see our current power draw as well. So this is a very important metric. We saw our GPU temperature, we see the memory that's been used, we see the GPU utilization, and we see free memory, right? So to mimic another environment, let's go ahead and let's cancel this operation. So essentially, we're not using our GPU now. If I go NVIDIA-SMI, I see it dropping down, right? So our memory utilization went to 0. There we go. Power draw went down to 42 watts, and then even the temperature is coming down to 48 degrees Celsius, and so on, right? So let's have a look at our dashboard. It should reflect that as well. Now we should see these graphs going down. So let me go last 15 minutes instead. So yeah, there we go. So this was when we ran the script, and then that's when we were using our GPU, and then when we stopped our script, we see that it's going down, right? So we see that across everything here. The temperature is going down, utilization going down, memory use is going down, and then this is going up because this is the free memory. So yeah, thank you for watching this, and I hope you guys learned something from this.